Okay, so Unit 4, Lesson 5 is talking about rational exponents or fractional exponents. Okay, so complete and evaluate the following. So we know that, let's just go to review this. Root 5 times root 5 is what? No. Root 25. Okay, root 25 square root 25 is 5. Okay. So we're trying to figure out what 1 over n is, the meaning of a to the 1 over n. So let's go right here, and this is going to help us figure this out. 5 to the 1/2 times 5 to the 1/2 is what? 1/2 plus 1/2, which is 1. Do we see that connection? We're using our exponent laws to prove this. We're on 93. 5 to the 1 equals 5. So do we see the connection? Yes. Deduce the meaning of 5 to the 1/2. 5 to the 1/2 is equal to square root 5.
Oh, I get it.
It's okay. We're going to keep going. Just up, we're done. Mike's got it. Okay, so here we go again. So cube root 2 times cube root 2 times cube root 2 would be cube root 8, which is 2. 2 and 1 2 and 1 2 to the 1/3, 2 to the 1/3 to the 1/3 again would be 1/3 added 3 times, which would be 1, which we'd get 2 again. So then deduce the meaning of 2 to the 1/3. 2 to the 1/3 is cube root 2. Now, wait a second. Let's just make sure we remember square root, what's up here? A 2. So are we seeing the connection? 1/2 for square root, 1/3 for cube root. Hey, opening doors. Exactly. I know, stop it. Take the headband off, you might have a better chance, Sander. Alright. Okay, so write the following in radical form and evaluate manually, so not use a calculator. Then verify with calculator. So 25 to the 1/2. So what this means is 1/2 means what? Square root, correct? So then our answer is 5. Want to see another thing I'll show you real quick? You can write 25 as what? 5 squared, right? What's our power to power rule? What's 2 times 1/2? 1. 5. Hey! Magic again. You guys like magic tricks. Okay, 64 to the 1/3 is cube root 64, which is 4. Okay, and 4th root of 81. Okay, and that's going to be 3. So now we went from rational exponent form to radical form. Now we're going from from exponent form to radical form. So we're changing these from exponents to radicals. Okay, so x to the 1/2 means square root x. So actually we're doing the same thing, sorry. Didn't mean to confuse you. Okay, b to the 1/3 means cube root b. P to the 1/10, 10th root p. We don't see that very often. And n root a. Good. Use this right here. We're just proving the definition. N root a. Very nice. Okay. All right. So complete and evaluate the following. So now, this one's a little bit different here. Let me move it up so we have some more room. If I'm going too fast, let me know and slow down. Okay, so complete the following. Square root of 5 cubed times the square root of 5 cubed. Well, remember, what's our rule when you multiply two roots with the same inside? What is root 5 times root 5? No. It's just 5. Well, it's going to be root 25, and then that's what? 5. We talked about with square roots, when you multiply the same root by the same root, the radical goes away. So this answer would be 5 cubed. Nope, 5 cubed, same thing. Okay, it would be 5, 6, Mike, but it'd be 5, 6 in the square root. Remember, what do we do with the index and the exponent? How many groups of 2 are in 6? 3, so it comes back to 5 cubed. And this would be 125. So okay, stay with me. So then 5, now 5 to the 3 halves times 5 to the 3 halves, we're going to add 3 halves. That's going to give me 6 halves, which is 5 cubed, which is 125. So then it says, deduce the meaning of 5 to the 3 halves. So now, what has changed? What were we doing before in our fractions? All of our fractions we were doing before, we had what on top? A 1, and now we have a 3. So, to deduce the meaning, this is 5 cubed square rooted. So this right here is your numerator. This right here is your denominator. 3 halves. Okay? Because we already talked about the 2's on bottom, right? Let's try another one. Any questions on that? This is where it starts to get a little confusing. I will tell you the thing that makes things easiest for you. Understand the bottom of the fraction is always going to be your square root, cube root, fourth root, whatever. And then the other one, you just remember, oh, I put that inside. Okay, the bottom is your index. Okay, so I've come down here to the cube root example. So I have 3 of them. Okay, so my answer is going to be 2 squared or 4. Because there's 3 of them. Just like above. So then if I do this, 2/3, I'm doing 2/3 plus 2/3 plus 2/3. That gives me 6/3, which gives me 2 squared, which gives me the 4 again. So deduce the meaning of 2 to the 2/3. It'll be cube root of 2 squared. Yeah. Okay, x to the 5/3. So write that in radical form. So what's my index of my radical? 3. So cube root of x to the 5th. Good? Sure. Okay, then this one, what's my root? 5th root, b to the 4th. Okay, Xander, what's my radical here for part 3? Of these two? Like 5 or 2? Which one goes up here? The 2. Good. That's all you need to know. And then you have a P5. Okay, good. So then the definition, which is this, the definition is you have nth root of a to the m. Nth root of a to the m. Alright, now it's pretty much Got a couple more, and then we fire through some examples. All right. All right. Okay, so evaluate 8 to the 2/3 equals 8 to the 1/3 squared. Okay, or 8 to the cube root 8 squared. So you want to evaluate. Okay, well, what is the cube root of 8? 2. 2 squared is 4. So 8 to the 2/3 is 4. Let's look at this one. 8 to the 2/3 equals 8 squared times 1/3, or cube root of 8 squared. Cube root of 8 squared is cube root of 64. And the cube root of 64 is 4. So what it's doing is it's showing you all the connections. Showing all the connections of different ways you can write this. So what's 1/3 times 2? 2/3. What's 2 times 1/3? 2/3. So there's just different ways you can write it. And then they convert this one, okay, into this. So cube root squared. And then they convert this one, cube root squared. Okay, so just different ways of writing it. Which of the calculation above is the easier method for evaluating? I don't know. I think they're about the same. Do you guys have a preference? Maybe the left one? Okay. Say that one, I guess. Okay, write the following radical form and evaluate mentally. So turn out to use a calculator. So 64 to the 3/2. So I want square root of 64 cubed. Okay, what's that? Okay, so look at this one here. It's kind of a big number, right? Well, look how this one's written though. The 2/3, they did the cube root and then squared it. See the 2? So let's do it that way. So let's square root it and then cube it. So what's the square root of 64? 8. And now we can go 8 cubed. 512. A little bit easier way of seeing it. Obviously, you couldn't do 64 cubed in your head and square root it. That'd be pretty hard. Okay? So let's try that this way here too. So we got square root of 4 to the 5th. We all know what square root of 4 is. Okay, it's 2. And then 2 to the 5th is 32, yeah. Sorry, I almost wrote 16. 32. Okay, and this one, 4th root of 81, and then we're going to cube that. So what's the 4th root of 81? 3. 3 cubed, 27. Okay, use exponent law to simplify these two. Well, what's 2/3 plus a negative 2/3? 0. What's 8 to the 0? 1. Good. Okay, use the result in A to write A to negative 2/3 in the form with a positive exponent. So, this is what we kind of talked about today. If I had 8 to the negative 2/3, where would I push it? Down. Good. So it'd be 1 over 8 to the 2/3. Now we'll go ahead and do 8 to the 2/3, which would be cube root 8 squared. What's the cube root of 8? 2. What's 2 squared? 4. So do you guys see? Your answer is 1/4. Because 4 is on the bottom. questions, concerns? Okay. All right, so we'll finish this up, and then we have some examples to go through. All right, so the last thing we're going to talk about here is the rational exponents. So here's what we've learned so far, just kind of breaking it down. So a to the m over n means m is what your exponent is, and n is your index of your radical. There's a couple different ways you can write it. You can write it like this, which we thought was the easiest. Okay, or you can also write it like this. If you have negative fraction, you push it down to make it positive, and then it's the same from above, just on the bottom of the fraction. So the negative rule is the same. We're pushing it down to make your exponent, or excuse me, yeah, your exponent negative, positive, from being negative. Can't talk. All right, let's do some examples. All right, example 1. Okay, so write the following radical form and evaluate without using a calculator. So let's do, all right, let's start with Tatum here. So Tatum, tell me how to write this in radical form. Okay, good. And what's the square root of 25? And you know what 5 cubed is? No, 125. Okay. All right, Janae, part B. Okay, and cube root of 1,000 is? And you know what 10 to the 4th is? 10,000. Good. All right, Brandon gave you the negative one. So what are you going to do first? Say it one more time. Okay. We don't want to make a negative square root. We just want to push it down. So it's just cube root 27 and then squared. So what's the cube root of 27? 3, and then what's 3 squared? So the only thing that happens is it's 1/9 instead of 9. Okay, 1/9 instead of 9. Good. Mike, you have another negative? 16. Okay, and then what's the 4th root of 16? Yep, and then what's 2 cubed? No, 8. Okay. All right, Xander, part E. Okay, good. Can we cube root of negative 8? Yes. It's an odd, right? You can odd root negatives. So what's the cube root of negative 8? Negative 2. And then what's negative 2 squared? 4. Good? All right, Josh. So now what's the difference between E and F? What's that? Right, there's no brackets, which means the negative is not being affected by what? Not the 8. The 2/3. Yeah, the 2/3 is only on the 8, not on the negative. So your negative is going to kind of hang out and be in your problem the whole time. Okay, so what you have is you have a negative out here. And then how do I write this in radical form? How do I write 8 to the 2/3? It's going to be cube root of 8 squared. Right? So 2 squared. Cube root of 8 is 2. See, and what happens, the negative just kind of hangs out. 2 squared is 4, but the negative hits it at the end. So this one's a negative 4 opposed to what we had last problem. Make sense? Kind of? Molly, part G. Okay. Okay. Good. So what happens here is, and this is an exponent thing, if they're being added, you cannot distribute power to power rule. Power to power only distributes on what? Multiplication rule, okay, when they're multiplied. So if this was 3 times 4 squared, I could go bam, bam, hit the 2 there, and then work from there. But you can't, so that's why Molly went ahead and put those together, figured out what those were. She got 25, which makes her feel like she's doing it right because square root of 25 is 5. Okay, good? Doing good? Staying awake? It's not Monday, we can't sleep. Okay, example 2. All right, final run here. So example 2, let's see, we got Allie. So write the following in radical form. So just don't worry about the fractions, just write what would that be in radical form. So just think about what would we learn today. So what does the 2 mean? Square root, okay? Square root of 9/4, right? That's all you need to tell me. And then we're going to what? Cube it. Okay? Well, how do you square root fractions? You do it to the what? Top and bottom. So what's the square root of 9? 3. Square root of 4. Now I cube that. Yep, just like we just did. So 27 over 8. Okay. Similarly, Jad with a negative now. So it's going to be exactly what we just did here, but to get rid of the negative, what do we do? And this is what we just kind of talked about in the warm-up. What do we do with negative exponents? Okay, I'll show you that. Let's go with Chris since you weren't here for that. Chris, what do we do for this one? Push it to the bottom. So it's going to be 1 over 9/4, 3/2. Okay? So remember, negatives, you push them down. Now, essentially, we already did this work, didn't we, Chris? It's right here. So what do you think your answer is going to be over here if you had to make a guess?
1 over 27 over 8.
Right, which simply means it's flipping. So your answer we're expecting is 8 over 27. Let's see if that's what we get. Okay, so let's do this here. So we're going to do square root of 9 over 4 cubed. So on the bottom, I still have a 1. Square 3 over 2. I'm going to cube that. I get 1 over 27 over 8. Okay. Right, so it's a 1 over 27 over 8. Well, on top, there's really a 1 over 1 and a 27 over 8. And I always teach it like this. A fraction over a fraction, you have an underachiever and an overachiever. 8 over 27. Yeah, you just flipped it. That is correct. Okay? All right. Okay, Breezy, how do I write this in radical form? R to the 1/3. Good. Cube root R, very nice. Okay, Taylor. Seventh root S to the 4th. Okay, you put the 4 here, or you can put it there. Doesn't matter. Josie, you got a negative exponent. What are you going to do? Good. So you push it down. And what does t to the 1/6 turn into if we're putting in radical form? 6 is on the bottom. What's 6 on the bottom mean? That's the index of the radical.
Oh, yeah.
So 6. That's all I wanted. You're done. Okay. All right. So Tatum, back to you. I have a negative fraction. So where does it go, or what happens? 1 over. Good. Square root of v cubed. So she pushed it down. The 2's in the bottom, so square root of v, the whole thing cubed. Okay, good. All right, 3 more. Okay. All right. Okay, consider the following powers. Explain why 3 of the above powers can be calculated, but the other has no meaning. Okay, so 64 to the 2/3. So that means cube root of 64 squared. Is that okay? We can do that, right?
Yeah.
Okay. Next one. Cube root of negative 64 squared. Can we do that?
Yeah.
Yes. Okay. And then we have here square root of 64 cubed. Can still do that. And then by process of elimination, negative 64 square rooted cubed. We cannot do this one because square root a negative. We can't do that because it's square rooting a negative. Okay, a cube, so a cube means all the sides are what? The same. Write the power, which represents the edge length of the cube. So in terms of a power, how could you write that with an exponent? What do you think, Janae? How could you do that? Right, because we want a cube root, and 1/3 is cube root. Good. So 60 to the 1/3 is how you write that if you want to find a single side. Now, I think it's neat. You may not, but in your calculator, if you do cube root of 60, or if you do, you can do fraction exponents in your calculator. You can get the caret. So like in your calculator, you can put it in like this. Caret to the 1 divided by 3, and it'll cube root it for you. Okay, and it'll cube root for you. So write the power, which represents the surface area of the cube. So what is the surface area of the cube? Interesting. Well, we know that this represents what? One edge. So what is the surface area of a cube? How many sides are there? 6 times? No. What's 60 1/3 times 60 1/3?
1.
What's 1/3 plus 1/3? 2/3. Right? Because I'm timesing, we have a cube. We know that the 60 1/3 is a side, and a 60 1/3 is a side. When you times those, we do what the exponents, we add them. 1/3 plus 1/3 is 2/3. We have the 6 there because there's 6 sides. Okay, very good. Use a calculator to calculate the edge length to the nearest tenth. So in your calculator, if you put this in your calculator, you would get for the edge length, each edge length is 3.9 meters, and the surface area would be 92 meters squared. Yeah, just the division button. Some of you, I think the newer ones have the fraction button too. Yeah, there's a fraction button where you can insert it so it looks more like a fraction. Okay, and last example. Okay, so write the number 10 in the following forms. As a power with an exponent of 1/2. Okay, so you want the answer to be 10. That's what it's saying. It's not 10 to the 1/2. What will give you 10? So what's square rooted is 10? 100 to the 1/2, right? Okay, it's a power of 1/3. So what cube root? We did it earlier. 1,000. Yep, good. 1,000 1/3. These all equal 10. All right, good deal.